In this video, we're going to cover 3 learning objectives. 1.1a is going to have us display data as a bar graph of the distribution of a categorical variable. B is going to interpret a pie chart and recognize when it can and cannot be used. And C, identify what makes some graphs deceptive. First vocab is a frequency table, and what that is it displays the counts in each category. So the counts are just another name for the frequencies. Whereas the relative frequency table actually shows the percents in each category, and that's also referred to as, again, relative frequency. Now you will be careful, sometimes you will see a round-off error, and that just means the exact percent would add to 100, but the rounded percents only come close. And that is going to be okay if you have a rounding error. Our first example deals with the majors that you could get at a certain college for a bachelor's degree back in 2007. So here we have a list of all of the majors, which would be a categorical variable. This first column is the number of degrees, so that's count. So this component here would be the frequency table. They then computed the percent, which is taking the counts over the total for each particular variable in here. Having the percentages here also makes this a relative frequency table. So the first question, identify the individuals in the table. In this one here, the individuals are the degrees that were granted. Then identify the variables and how they were measured. They were measured by the field in which the degree was granted. Letter C wants us to compare the middle column, which is here, and the column to the right. We've already talked about that a little bit. The middle column actually shows the frequencies that we see, whereas the column to the right shows the relative frequencies. And then D, when is it better to use the percent column on the right versus using the counts or the frequencies? One answer for that could be is if you want to make a pie chart. A lot of the times when you see a pie chart, remember a pie chart is just a circle where they have different sectors sectioned off to it. It's best to see what percent each piece of pie represents. I will tell you the AP exam says they are not going to require you to do anything with pie charts in particular, so this is just a good, nice to know. Another thing you could say is it's good to use them is to emphasize the category in relation to the whole. When you really want to make a good story, let's say for a particular major, you're trying to sell the business major, and it's a big piece of the pie, a pie chart might be a great way to really represent that nicely. So what a pie chart actually does is it shows the distribution of a categorical variable as a piece of pie whose slices are sized by either the counts or the percents, and they must include all of the categories to make up the whole. So if you do not have all the categories, you cannot make a pie chart. How about a bar graph? Well, a bar graph represents each category as a bar, so it looks like the categorical variables. The bar heights show the categories, again, counts or percents. Now, bar graphs tend to be easier to make than pie charts, and they are also tend to be easier to read. So especially in the AP exam, you're going to see a lot more with bar charts and probably very little to nothing with the pie charts. Let's look at another example. Here we're looking at some devices. These are the percents of 15 to 18-year-olds who own the following personal media devices. So our category are the devices, and here they all are listed. And here's the percent who own these devices of the students that were surveyed. Here they want us to make a well-labeled bar graph to display the data. So to make a bar graph, what you're going to want to do is to put each category on the horizontal axis down here. Here we're given the percents, so percent to own label on the vertical axis. And when you do make your bars, make sure that they're the same width and they're not deceptive and that they have a similar vibe to each other. So if I've already made this graph, here's what it would look like. Now you do need to be cautious here. AP common mistake says many students spend lots of time constructing graphs only to forget the labels. You need to communicate your graphs with proper labels and scaling. So if you forgot in particular to put this label here, or that your scales were not correctly spaced out, they want a reasonable scale that is not distorted. You will lose credit on a very easy task. Now they want to know, would it be appropriate to make a pie chart for these data? Here's just a quick snapshot again what that table looked like. If we made a pie chart for that, keep in mind this was a percentage. So when they asked the students, this shows 85% had a cell phone and 85 had an MP3 player. Well, this absolutely does not represent the whole. These totals exceed the whole, so this is not how those totals were computed. So response for that, no. Each percent in the table refers to a different device, not the parts of a single whole, so it would not work in this case. Part C, why do statisticians prefer bar charts over pie charts? We already talked about that. They're just easier to make and read. Now, if we talk about what's wrong with graphs that might be misleading, here's a really good example. This looks like it's an ad that DirecTV did, probably in the USA Today newspaper or on their website. And they have here that it looks like it is 95% or 95 total. I'm not even sure on that one. So from that, it's not even the best graph. Let's assume that means 95%. So 95% of the people watch DirecTV, 81 do dish, and 56 do cable. What is misleading about this graph? Well, one thing you might say is misleading is look at the actual heights of the bars. If this is 95% high, 81% here is almost half of that 95% bar, so that is very deceptive. So the first thing I would say, the heights of the bars are not accurate. The other thing that's very deceptive is actually the width of the bar. Obviously, they want you to buy DirecTV. That's their focus. This is very wide, this is narrow, and this is even more narrow. So the extra width for the DirecTV is incredibly deceptive and is going to make consumers of this ad probably go more toward the DirecTV option. That's the end of learning objectives A, B, and C. Go ahead and try the practice problems.